this is Himanshu, and in this lecture, we will study about the black holes. Now, as we have studied in the earlier lecture, that the supermassive stars, which are actually 5 to 6 times the mass of the Sun, the high gravitational pull at the center is because of the high enormous mass. And because of this, they have a fusion reaction at a very, very high rate. And then there comes a time when the star will expand and eventually it will explode, and that explosion is what we call as a supernova explosion. Now because of this supernova explosion, there will be a strong recoil, and that strong recoil, or we can say and what we call as an implosion, yes, strong recoil, let me write it here, or we can call it as an implosion. Because of this, the material collapses into the point of a singularity, that is basically called a single point. So let me write it here, that then the material will collapse into a singularity. Now this point of singularity is what we call as a black hole. Now the dimensions of the black hole are still not clear to us because of the so much matter is compacted into a point. So it has the most intense gravitational field, and the ends of the gravitational fields of the black hole is what we call as the event horizons. So here's another word that you need to remember is the event horizons. So the event horizon was actually the ends of the gravitational fields. The ends of gravitational field of black hole. Now in that point, it has a lot of kinetic energy, and the fusion reaction is also taking place. The electromagnetic energy is also released in the form of a light energy, and because of this thing, when the light travels through it, or when the light is caught by the black hole, it gets bent because of the strong gravitational field. So yes, the light does get affected due to the gravitational field. This was a question that UPSC has asked, the previous year, whether the light got affected by the gravitational field or not. So answer is yes, it does. And the black hole is a proof for that, because the light, when it goes in that, due to intense electromagnetic and the gravitational field, it bends, it takes the form of a spiral. So generally what happened when in the supernova explosion, that implosion is nothing but a contraction, and this contraction is sometimes what we call as a Schwartz child radius. So there's another word that you need to remember, and that's called Schwartz child radius. Now this basically says that every star there is a critical radius, and if the critical radius is below this, then the supermassive star will not become the black hole. So the radius of the star should be at least this one or greater than this. Only then the supermassive star can become a black hole. And if it does, then if a material of the star is closer to the event horizon, the material will be spiraled into the singularity. The singularity will be look like this, huh? So let me make with a black pen. So that is where the event horizon will be, and then when the light comes here, the light will spiral into the center. So here, yeah. So this is what it looks like, and here this will be event horizon, and this would be like a spiral into point of singularity. Now this matter from the neighboring star forms a disk-like structure around the black hole, and that is called the accretion disk. So I hope you got it, that when you black hole itself, it consumes everything, it is cannibalistic, right? When it consumes the matter which comes into the contact of it, it creates a structure around it, and that structure is what we call as an accretion disk, or sorry, accretion disk, not accreditation, accretion disk. And if the black hole develops an accretion disk, only then it can be identified. Means that is the only condition to identify black holes. So the matter is actually the made up of the particles and the antiparticles. So as we have discussed earlier in the fundamental physics, and also this is said by the Stephen Hawking also said the same thing. So when reaches an event horizon, there is a chance, a very slight chance, that these particles and antiparticles escapes the gravitational field. And when such thing happen, the radiation which is formed, and this is what we call as the Hawking radiation. So I repeat it again. What is it basically? When the matter comes in contact with the black hole, an accretion disk is formed. And sometimes what happen, these particles of the matter, that is the particle and matter, the particle and the antiparticle together, they try to escape from the gravitational field, and sometimes they does. And when that happen, the radiation is formed, and that radiation is called the Hawking radiation here. Now, that therefore the black hole can be identified by the Hawking radiation or the event horizon, or by the by the accretion disk. So we have now the three of them. So we have one accretion disk where we can find it. Now the another one is basically the Hawking radiation, from where we can find it, or the next one is that we can either have an event horizon, that is basically a spiraling of the light itself. So these are now the three conditions here from where we can easily determine that whether the black hole exists or not. Now continuously the black hole is consuming the material from the neighboring star, as we had told you that it is cannibalistic. Now by this, black hole will consume all the stars of the neighboring galaxies. It will consume, definitely. And then there will be a point where, when the black hole would consume all the star of the galaxy and become extremely unstable, and at that point it suffers an explosion and give birth to the stars. And this is a cycle, and therefore the Big Bang will take place next time again. So this is what we say, the universe is created by the Big Bang, but the Big Bang itself is made by the black hole. So yes, the black hole will consume everything and it become unstable. Then again that singularity point will break, the big crunch will happen, the state of big crunch, and then there will be a Big Bang again. And when such thing happen, the stars and the galaxy will be created again. So this is the whole theory of the Big Bang and the black hole, starting from here. So this is the mainly about the black hole and how everything works. And I think now you're in a very good position in handling questions. If something comes out regarding the event horizon, or the accretion disk, what are the reason, how can we determine the black hole, what are supernova explosion, Chandrasekhar limit. Sometimes they usually ask in the prelims these questions. So this is concept are pretty much regarding the science and technology also, and the geography also. So yes, that's it. In the next chapter we will study more about these things. Thank you guys.